Okay, next, let's answer this question, self-exercise 2.8, page 54, number 2. Okay, the question state here, find the equation of tangent and normal to the curve. Okay, equation of tangent and equation of normal to the curve, and this is the equation of the curve. Okay, before that, let me explain to you all the concept. Okay, the concept of gradient of the tangent to a curve at a point. Okay, so we have learned for all curve, okay, right, they have an equation. So let's say this curve, this is the equation of this curve, and its first derivative, okay, dy by dx, is the gradient function. So after you find dy by dx, so here you get 4x minus 3, right? This is known as gradient function of the curve, okay, where it's used to find the gradients of the tangent to the curve, right? It's used to find the gradient of the tangent to the curve. So if you have a curve, okay, if you have a curve, so each point on the curve here, let's say dekat sini, at this point dia ada tangent dia. Let's say here dia ada tangent dia sendiri. Dekat sini dia ada tangent dia sendiri. Alright? So how to find the value of the gradient of the tangent at point A, point B, point C here? How? So that's why, okay, you need to find dy by dx. So once you find dy by dx, it is in terms of x. Is it correct? Yes, teacher. Right, you can see it is in terms of x. So you get 4x minus 3. Right. Okay, so how to find the gradient? This is gradient function of the curve. This is known as gradient function of the curve. Right? Okay, so how to find the gradient at point A, point B, and point C here? Specific point. How? So you just substitute the x coordinate there. Okay, let's say you want to find the gradient at point A, so x here you put in as 2. So 4 times 2, 8, 8 minus 3, 5. So teacher, I know the gradient of the tangent at point A is 5. Let's say point C here, the x coordinate is negative 1. Okay, negative 1, the y coordinate not given. Okay, so if x is negative 1 times 4 minus 3, what do you get? Negative 7. Right, so this one, this line is dia tak betul lah position dia. Sebab kalau dia positive gradient, kan kita belajar positive gradient dia sepatutnya slope dia macam tu. Ini positive gradient. Kalau you ada negative gradient, slope dia sepatutnya macam ni. Ini negative gradient. If like this, gradient is 0, parallel to the line parallel to the x-axis, right? So sepatutnya dekat sini, sebab saya dapat negative 7, sepatutnya gradient dekat situ, this tangent, maknanya tak logik lah kalau saya letak x as negative 1. Maybe x here is 1. Kalau saya letak 1, 4 minus 3 become positive 1. Then only correct. This gradient is positive 1. Faham? Okay, ini sebab saya tak, saya just lukis saja. Okay, so dalam soalan jangan risaulah, dia akan bagi benda yang betul. Okay, right, kalau you dapat positive gradient, maknanya line you sepatutnya macam ni. Tangent you, position dia macam ni. Kalau you dapat negative gradient, meanings tangent you, position dia macam ni. Slope dia. Okay, okay, let's say dekat B, x is negative 2. Let's say. Ini tak tahu y tak tahu. Okay, if at B, how to get the gradient at point B? So put in x as negative 2. 4 times negative 2 minus 3, you get negative 11. So correct. This one betul lah. Okay, slope dia incline to the left. Okay, negative gradient. Okay, so itu yang pertama yang you kena faham, that this one. Okay, every curve has an equation. And from the equation, you can find the gradient function of the curve. Okay, once you get the gradient function of the curve, how to find the gradient of the curve at the given point? You just substitute the x coordinate there. Okay, let's say here, you want to find the gradient at A, put in x as 2 in the gradient function, into gradient function. You want to find at C gradient, you just put in x coordinate as 1 in the gradient function give, okay, of the curve. And if you want to find point B punya gradient, put in the x coordinate at the point B here, okay, in your gradient function, then you will get the value of the gradient there. Okay, so itu yang pertama yang you kena faham. And then lagi satu benda yang you kena faham, okay, gradient of the curve is defined as gradient of tangent to the curve. Okay, maknanya, let's say at point A, gradient of tangent at A is 5. And gradient of the curve at A is also 5. Why? Because we have learned this. Gradient of the curve is defined as the gradient of the tangent to the curve. And how to get the gradient of the tangent? You must use, okay, this. Always remember this. Gradient of the tangent is dy by dx. How to get dy by dx? Okay, differentiate from the equation of the curve. This is equation of the curve. Okay, and then once you differentiate, you will get gradient function. So this is known as gradient function of the curve. Why we call it gradient function? Because it is in terms of x. And how to get the value of the gradient? Let's say at point A here, okay, the x is 2, right? So to find the gradient of the tangent at A, okay, now this is the gradient function. The x coordinate right now is 2, right? So put in x as 2. X is 2. So 4 times 2, 8. 8 minus 3, you get 5. Okay, so the gradient of the tangent at A is 5. Right, so you understand the gradient of the curve at A is also 5, the same. Okay, itu yang pertama yang you kena faham. Sebelum you nak jawab soalan ini, before you answer this question, you must understand this concept. Okay, kalau tak faham ni, nanti tak boleh nak jawab ni. Faham? Sebab, okay, once the question asks you to find equation, okay, dalam otak kena set. You kena ada apa? First, you need to find the gradient. Second, you must have a point. Why? Because you need to apply this formula. To use this formula, you need gradient and you need a point. Okay, so you need this gradient and a point, right? So that you can substitute here. M here represent this is bracket, okay. So M here represent gradient, and then you need a 1 point to put in as x1 and y1. Okay, okay. So first, let's find the equation of the tangent first. Oh, before that, one more concept. You must understand. Once you have tangent, okay. Let's here you have curve. Right, so at every point on the curve here, they have a tangent there, right? So let's say at point A here, once you have tangent, okay, of course you have normal there. This line, okay, intersect 90 degrees at point A, and this is known as normal to the curve. This one tangent to the curve at point A. Okay, so once again, they ask you to find equation of normal. Again, you need gradient and a point, right? So, how to get the gradient of normal? That's why, first step, you must find the gradient of the tangent to the curve first. Then, how to get the gradient of normal? Use this concept. Okay, gradient of normal times gradient of tangent always equals -1. Okay, normal meet tangent at 90 degrees, right? Normal meet tangent at 90 degrees. Okay, so benda ni kena ingat lah, kena hafal, kena faham. Okay, so then let's say here, just now we get the gradient of tangent here is 5, right? So tadi ini curve U, this point A, right? And then we have already find the gradient of the tangent here. We get 5, right? So how to find the gradient of the normal here? This is examples, not this question, okay? Okay. So this is normal. How to find the gradient of normal here? Of course, kalau you nak cepat, saya kata pakai je m negative 1 over m. Ingat lagi? You still remember? So, if the gradient of the tangent is 5, of course the gradient of normal will be negative 1 over 5. M is 5, so the gradient of normal become negative 1 over 5. Okay, so or maybe you use this formula, m1, m2 equals negative 1. 5, tangent gradient, m normal, you want to find it, so that's why the gradient of normal become negative 1 over 5. So this is the concept, okay, yang you kena faham before you start answer this question. Okay, now next, let's answer this question.